Today we're going to talk through coordinate proofs. We've done a homework problem with it before, but we're going to make sure that we have the establishment of the idea here. The idea is that this is another way to prove triangles congruent, but instead of explaining the thought process you're using given information, you're using formulas. So what we're going to do is we are going to be using the distance formula. We're going to be using side, side, side to prove the triangle's congruent. I'm going to start with side A to B. And we are going to show distance formula. I'm going to show the details with this first distance formula, but I don't want you to lose big picture. Big picture here is that we want 3 pairs of sides that are matching. We want matching distances because if they're the same distance, that means that they're congruent. So let's get our distance from A to B. I'm going to go in detail here because this one's tricky. There's a lot of negatives going on, and I'll give a bit less detail and have you be a bit more independent as we go on. But for A to B, subtract your x coordinates squared. My x coordinates here are -3 and -5. I'm going to take -3 and -5, subtract them squared. Plus, subtracting the y coordinates squared. The y coordinates here for A and B, y coordinates are -1 and -4. So we're going to take -1 and -4. We're going to subtract them squared. Equals -3 minus a -5. Remember, subtracting a negative is the same as adding. So -3 minus a -5 is -3 plus 5, which is 2. Then we have -1 minus a -4. -1 minus a -4 is -1 plus 4, which is 3. Two squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. Remember, squaring means multiplying something by itself. So that will equal the square root of 4 plus 9 is 13. So that's all your details of the distance formula. Questions up to that point? Okay, zooming out from all those details, remember, big picture. We are looking to match a side on the other triangle with this distance from A to B. Was this a translation, rotation, or reflection? It was a translation. It was shifted up and to the right. So if it was a translation, we have A to B. Which side in the other triangle should A to B match up with? P to Q. So we're finding the distance from P to Q, and we're hoping to get what? Square root of 13, hopefully, because then that would tell me the sides were congruent. They were the same distance. I'm going to go quicker this time. Square root of, subtract the x coordinates. My x coordinates here are 4 and 2. I'm going to subtract them, squared. Plus, subtract your y coordinates. My y coordinates are 5 and 2. So I'm going to take 5 and 2 and subtract them, squared. 4 minus 2 is 2, squared is 4, plus 5 minus 2 is 3. Squared is 9. 4 plus 9 here is 13, and we get the square root of 13. Ding, 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 we have a match. So since we have that match, we're going to write out that those sides are congruent. We're going to say since these distances ended up being equal, that means that segment A to B is congruent to segment P to Q. And just like I was doing last week, I'm going to put a little S in parentheses to indicate that we were talking about and getting a pair of sides. So there is pair of sides number 1 down, 2 to go. So pair of sides number 2, we're going to start with B to C. And have you working a bit more independently now. I want you to find that distance from B to C. Then once you found that distance from B to C, think about what should B to C match up with in the other triangle and get that matching pair of sides. Then you'll have matching pair of sides number 2, and that'll leave matching pair of sides number 3 to do. So I'm going to give you a few minutes to work through that. There are your answers. I showed out the work for the second pair of sides, and then that's what you should get for the third pair of sides. And we have 3 pairs of matching sides. Therefore, this is the last thing that you want to put in the problem, so make sure that you say it, because the whole point is getting the triangles congruent. So make sure you write out the congruent statement. Triangle ABC is congruent to triangle PQR by side, side, side. Make sure you write out that congruent statement as part of your answer. Okay. We will walk very quickly through one of the things in this problem, but I want to focus in on one specific detail in this problem. So I'm going to kind of gloss over all the rest of it so that we can focus on the one detail that I want to focus on. I'm going to give these points labels so that we can label the sides when we find the distances. To do this, we would do the same thing. We would find our distance formulas and find our matching pair of sides. So we would start by finding the distance from V to X. I'm going to go nice and quick this time. My X coordinates are -5 and 0. Subtract those and square it. Plus, my Y coordinates are 7 and 0. Subtract those and square. -5 squared is -5 times -5 is a positive 25. 7 squared is 7 times 7 is 49. So I get square root of 74 as my distance. Then hopefully you should get your other distance to match it. Again, subtract your X coordinates squared plus subtract your Y coordinates squared. Again, you'll get 25 and 49, which is 74. Ding, 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 we have a match. So you would write, since V to X equals Z to X, segment VX is congruent to segment ZX, and then we would have our side. Again, going very quickly through the details, you would get another pair of sides. You would do distance formula, etc., and get square root of 45 here. and then you would do distance formula on the other one, and etc. You would get square root of 45. Hey, those match. You would get another pair of sides. Okay, now here's the part I want to focus on. Here's where this problem is different. This was why I wanted to point it out. Notice that it says that it wants me to use side angle side to do this one. Wants me to use side angle side to do this one. That means that in addition to those sides that I got with the distance formula, I must be able to get a pair of angles where I can just say, hey, this pair of angles is congruent and I don't need to do any more distance formulas. Raise your hand if you have spotted the pair of angles that we can get and match up with each other that we know have to be the same. Raise your hand if you see a particular pair of angles that we know and we have talked about. Good, good. All right. Here they are. It's the included angle between the two pair of sides I found. So we're going to name what those angles are. And then we're going to name what kind of angles they are. What kind of angles are they? They are vertical angles. Make sure we know the names of those. That's why we've been drilling all those vocab and spent Friday doing what we did. Vertical angles are congruent. And then we have our triangles congruent by side angle side. Because we found the distances to get our first two pairs of sides. Then we got the included angles because we knew they were vertical angles across from each other. And vertical angles across from each other have to be congruent. So something to keep in mind is that your homework is going to be a mixture of these kinds of problems mixed in with what we had done in our first group of notes where we actually walked through a proof of getting triangles congruent. So your homework is going to be a mixture of those things. That's what you'll be seeing.